Hi all, I have just tried to make you a video and it's all gone pear-shaped, so I'm going to try again for the last time. I was really trying to avoid this, but the YouTube videos just aren't really any good for what I'm looking at here. So I'm on page 5. If you turn to that now, I'm looking at the title, Determining Physical States of Matter. And I'm looking at this while I'm talking to you. What happens here is that I've given you a wee table, and what I want you to do is use this as a rule to try and figure out the states of matter at different times. Now, it doesn't just happen randomly. They don't just say, here's a random element, what is the state of matter? What they do is they're asking you really a different question, okay? They're asking you if something is a solid. Let me clean the screen there. It's got rubbish all over it. They're asking you if something is a solid, a liquid, or a gas at room temperature. Now, the first thing that you need to know is you need to know what room temperature is. Okay? Now, room temperature for you at this stage is 25 degrees Celsius. So the kind of questions we are looking at here is we are looking at answering is, and it could be any element or compound at all. So we're going to call it X. The question could be, is X a solid, liquid, or gas at, and then it's going to be room temperature. Okay, they'll ask, because they'll want you to know what room temperature is. So is X a solid, a liquid, or a gas at room temperature? And you should know then, look, room temperature is 25 degrees Celsius. So really important that you know that. So we're going to keep that up there. And the question we're going to keep here is is X a solid, liquid, or gas at room temperature? Now, what they'll do is they'll probably give you the melting point and the boiling point. So the information you're going to be given is you're going to be told, look, X has got a melting point of, and they'll tell you what it is, and then it's got a boiling point of something else. Okay, those are meant to be question marks. They don't look like it, but they are. Okay, so this is a question and that's the information they're going to give you. Now, there's a few key things. I've given you a bit of an exam cheat here on the page if you can wrap your head around it. Okay, but I want you to think about the whole process here. Now, if I get a different colour, what is happening here is we're starting off and we're looking at what happens when we increase the temperature. That's what we're looking at here. Okay, oh glory, that's gone a wee bit wonky. Let me redo that. When we increase the temperature, what we do is we change the state. And we know that. So the coldest state that anything could be in is a solid. So it is a solid. Okay? When we heat a solid up, it changes then into a liquid. And when we heat a liquid up, it changes into a gas. And if you don't know that, then you're going to have to go back over the pages that you should have already covered before listening this to make fun of me. Okay? So, you've got a solid, a liquid, and a gas. They change towards the gas the warmer they become. Now, when you heat up a solid till it becomes a liquid, that temperature at which it becomes a liquid, you should know, is called the melting point. And you should have already written down a definition for melting point, okay? So the temperature that the solid changes to a liquid is called the melting point. When a liquid changes to a gas, that temperature then is called the boiling point. And this little table is based on melting point and boiling point, okay? And if you're asked, is X a solid, a liquid, or a gas at room temperature? Well, let's look at the example if it's a solid. So say X is a solid at room temperature. What that means, if we look at that, what that means is at 25 degrees, X is a solid. Now look at where the melting point and boiling point are in relation to that, okay? The melting point is above 25 degrees Celsius, and so is the boiling point. So if you look at the first column in your table, what you should be filling in here for the solid is that the melting point is above room temperature and the boiling point is above room temperature. And you should hopefully see that there. So if it's a solid at room temperature, it still needs to melt and it still needs to boil. So those two temperatures are above 25. Okay? Now, oh, something funny's happened. Looking then, if I get rid of that then, at the liquid, so say it's a liquid at room temperature. So at 20, what that means is at 25 degrees Celsius, X is a liquid. Well, look at where the melting point is now. The melting point is below 25 degrees, so it's below the liquid. So say you've got a glass of water beside you, it better not be any of that Boost beside you, boys. But say you've got a glass of water beside you. It has already melted before it's got to room temperature to be a liquid, but it's not a gas yet, so it still has to boil. So the melting point is below 25 and the boiling point is above. So if you look at page 5 there, in the liquid column, you should be writing the melting point will be below 25 and the boiling point will be above 25. Okay? And then if you look at the gas, hopefully you've got the idea now. If you look at a gas, something's a gas at room temperature. So the oxygen you're breathing in is a gas at room temperature. Well, what has happened? Look, the melting point is below room temperature and the boiling point is below room temperature. Okay? So if it's a gas, the melting point is below room temperature and the boiling point is below room temperature. So hopefully that helps you fill in your notes. I'm trying to move this out of the way and it's not working for me. Right, I'll have to deal with that. Now, if we look then at examples, okay, so if I take this off and we'll look at examples. So they have said X has got, they're going to give us an example now. X has got a melting point of, let me think, minus 132 degrees Celsius. That's its melting point. Okay. It's got a boiling point of 30 degrees Celsius. Where would you place 25 degrees? Well, look, 25 is above minus 132. Minus 132, I couldn't even imagine. I think I just freeze to death. Okay, minus 132 is below 25. 30 is above 25, so look at where room temperature would be. Room temperature would be a liquid. And that's how I want you to work these out. Try and imagine this little table. Use page 5. Okay, another example. If I give you another example, it's going to rub out for me. No, it's not. Why not? I don't know. Let me see. Yeah, get rid of them. Okay. So say the melting point is 660 degrees Celsius, okay. The boiling point is 2100 degrees Celsius. Where would you place room temperature? Well, hopefully you would realise 25 is much less than 660, so room temperature is here, so element X would be a solid at room temperature. Now I know that it's taken me over 8 minutes to explain this to you. If you want to fast forward or whatever, or you need to keep going over a few things, or you need to ask me some more questions, please go ahead. Hopefully that makes sense for page 5. It's a tricky one until you get it into questions and you get it into your head. But have a wee look. You can have a wee look on YouTube yourself if you think it might help you better. I couldn't really find anything that was overly helpful, so hopefully that helps explain page 5 to you. I hope you're all being good and you're taking care. And I'll hopefully chat to you soon, missing y'all. Bye.